Hi, I will explain my code for homework 5. First, I will go over the network 2 Python code. The first part, we create the cost functions. So for the class of cost functions, we then that defines the method for their functions and then define the method for their derivatives. And we can notice the function, cost functions just follow up the formulas given on the slides, and also the derivatives follow up the formulas, but we can make sure the functions are scalars and function results returned are scalars, but the derivatives will return vector which will have the same size as input, also have the make sure if for this one like cross entropy, if there's divisions, we'll make sure what we divided cannot be zero, and for log likelihood we have to make sure we have the derivative all the other zeros besides where the output y equal to 1, and also for our activation functions we also create those classes with their function methods and the derivative methods. Just follow up the formulas. It's straightforward. We can get those formulas to calculate the scalar returns, and also for their derivatives, we can just using the formulas as well. And like the redo function, its function is just max of 0 and c for this redo. But for the derivatives of that, just we can using the numpy heavyset function to do this one. And the next part I will talk about the regularization and add the dropout. What we added to this Python file, and in their initialization part, we have to just add these parameters for those two things and make sure, because if there's a dropout, we have to use a parameter to track if it is dropout, and if it is true, we also have to store a list of dropout masks that can be multiplied to all the layers. That is the part when we do dropout. So we are stored a list of the masks which can be multiplied to each layer within mini batches. So, and for the set parameter function, we also added the same things here. And then for feed forward, we have to see here we have the layers. We have to make sure for the hidden layers using the hidden activations, and for output layer we'll use output activations. And to modify to add the dropout, we have to multiply the activations for the hidden layers by their mask. The mask will create later on. So for the SGD part, we also have to modify that, because we only want the dropout happened for the training part, but not the test part. So we have to save before the evaluation test part. We have to set the dropout to false, and after the test part done, we can back off the dropout if there is dropout percent. And for the mini batches, we have to that is part when we create the dropout masks. So because we use the same dropout nodes during one mini batch, so we have to reinitialize the dropout mask for each mini batches. And for that one, we will create a list of the masks. So that is create using loop by scaling. We're using the formula given from the website to create the masks that can be multiplied to all the layers. And also for in the mini batch part, we have to do the regularization. So for the regularization, it is if it's none or if L2, they'll do the same. And just follow up this formulas given on the slides. And for L1 regularizations, so just slightly different formula to updating the weights. And for the both BIOSes, it doesn't change anything for the BIOSes if there's regulation. And for the backup prop function, we can still have to add up the dropout part, and also for the hidden layers and output layers, we're using different activations, and we multiply this dropout math if there's any, and yeah, that's for this backup part. And for the total cost, for this part we have to modify the regularization part. We can see for the none or L2 we're using one formula, and for L1 we have to make sure this ordering set to 1, we use L1 form, L1 norm. And also I noted here the reason why we set the non-regularization and L2 regularization using one formula, because if for the default one it's none, if it's no regularization, so the initial lambda is 0, so this part can multiply by 0 will be 0. So if it is non-regularization, this will be 0, so there's no regularization. But if it's L2, you can just added up this part, so there's L2 regularization and L1 regularization. We'll use a different formula. So that's it. And for the application part, I will just run all the experiments. So I can, for the kernels, to run all of them. So we can see all this experiments can be run. It's really fast because our data set is not really large, and after I compare to everything to the results on the website, everything are matched. So I think I'm pretty good on this. Okay, thank you for watching.